Hi guys, we're going to go over Chapter 5, Section 1 today, the history of the periodic table. By 1860, more than 60 elements had been discovered. Chemists used different atomic masses for the same elements, and this made it impossible for one chemist to understand the work of another. So in 1860, the First International Congress of Chemists met, and they all agreed on a standard values for the atomic mass. This allowed them to compare data and share their results. Dmitri Mendeleev is the person credited with the very first periodic table. He was a Russian chemist who organized the elements according to their properties and their masses, and he published it in 1869. He was the first person to notice a periodic pattern of the elements. So a periodic pattern is a pattern that repeats over and over again. Can you give one example of something that occurs periodically? Some examples are the phases of the moon. That's a pattern that happens over and over again, or magazines being released quarterly or monthly happens over and over again. Same thing with your class periods. You go to periods 1, 2, 3, and then 4, 5, 6, and then on alternating days, you repeat that pattern over and over again. Some elements, such as iodine, were placed out of order. So he put iodine after tellurium because iodine had the same properties as the other halogens. And he did this because of its properties. So he didn't necessarily put them in order by their mass only, but he was looking at grouping the elements by their properties. And since iodine was very reactive, like the other halogens, he put it in group 17, or what we now know as 17, the halogen group. And probably the most important thing that Mendeleev did was that he predicted the existence and some of the properties of 3 elements that had not been discovered yet. He predicted scandium, gallium, and germanium. In 1911, Henry Moseley discovered the reason that some of the elements were out of order when he reorganized them by their atomic number, which we know as the number of protons. So why didn't Mendeleev organize them by atomic number? If they fit into their columns better by atomic number, why did he not do that? When you look back at your 3.2 notes that we did, you'll notice that the nucleus wasn't discovered when Mendeleev came up with his periodic table. So they needed to find the protons with Rutherford's gold foil experiment before they could find the nuclear charge, which is just the number of protons that are in there because the neutrons are neutral. And that allowed them to have a better or fixed periodic table. So Henry Moseley is the person that fixed the elements that appeared to be out of order because their mass didn't fit into the pattern, but their atomic numbers do. Periodic law says that the physical and chemical properties of the elements are periodic functions of their atomic numbers. That means that as you go across each period, the pattern of their properties is a function. It's a pattern. It happens over and over again. So if I skip down here really quickly, in other words, group 1, these are all highly reactive metals. And then group 2 is a little less reactive. And then we get to these central elements that are all very non-reactive or fairly non-reactive. And then the reactivity starts increasing again until we get to group 17, which is extremely reactive, just like group 1. And then we get to the noble gases that are unreactive. And when we go down a period, that same pattern happens over and over again. Okay, so that is the periodic law. The physical and chemical properties of the elements are periodic functions of their atomic numbers. As you go up in their atomic number, the pattern happens over and over. The periodic table is the arrangement of the elements in the order of their atomic number. So the elements with similar properties fall into the same column, which we also call a group or a family. So these vertical columns from 1 to 18 are the families or the groups on the periodic table, and the period is the horizontal row. And notice there are 7 periods on the periodic table. So there's 18 groups from 1 to 18 across the top, and there are 7 periods. Valence electrons are the electrons in the outermost energy level. So when we were doing our electron configuration, the ones with the highest energy level, like 4s, for example, if we had potassium or calcium, their outer electrons would be in 4s. Those very outer electrons are called the valence electrons. And you can tell how many valence electrons are in an atom just by looking at where it's at on the periodic table and what group it's in. If we were to count the number of outer electrons in this atom, you would see that there are 8 electrons in this blue outer ring. So that would be one of the noble gases. Since it has 8 outer electrons, it would fall into group 18, known as the noble gases. Okay, so the group number along the top of the periodic table up here tells us how many valence electrons this group has. So group 1 has 1 valence electron, group 2 has 2. The transition metals tend to be a little tricky, but it's usually between 1 and 2, and we won't worry about them, so we're going to skip over. Group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7 valence electrons, and the noble gases we just said had 8 valence electrons. Okay, and that doesn't include helium, which can only hold 2 because it only has 1 energy level, and that very first energy level only holds 2. The octet rule says that atoms are more stable when they have a filled outer energy level. So these noble gases, where they're all filled up with 8 electrons, 2 in the s and 6 in the p orbitals, those follow the octet rule. So we say they have a full shell or a full set of electrons. Okay. Which group was that has full s and p orbitals and therefore is the most stable? That group happens to be the noble gases, these purple ones over here. And this periodic table shows us all of the different groups found within that periodic table. So we have this bright green. These are the alkali metals. They're group 1. They have 1 valence electron. The alkaline earth metals all have 2 valence electrons. The transition metals, again, they're tricky, so we tend to skip them in honors chemistry. And then we would have group 13 with its 3. These ones don't have specific names. You can look up the kind of strange names, the chalcogens, but mostly we worry about the halogens because they're very reactive. And then the noble gases. And lastly, at the bottom, we have the lanthanides and the actinides, which are technically not groups, but we group them together anyways because they have similar properties. And that's it for now. Have a great